If you just swap lithium batteries into your RV and you're not getting the performance you expected, you likely didn't know about two pivotal things that are going to make or break this system. Let's get into it and show you how to correct it. It's easier than you think. A lot of people like to overcomplicate this process, but when you're switching to lithium batteries from standard lead acid batteries, there's only two main things that you need to concern yourself with. Those two things are charging sources and monitoring the battery itself. So when we're talking about monitoring the battery itself, traditionally in RVs, we have a panel inside the RV that has those idiot lights. You push the button and it shows if you have 1/3, 2/3, or all the way full. Maybe it does it in quarter increments, whatever it is, right? Those are based solely on the voltage of the battery. Lead acid batteries have a voltage curve. As they get lower in state of charge, that voltage starts to drop off. A fully charged battery might be somewhere around 13 volts when it's resting. And conversely, when it's drained down, you can get down to 11.5 volts. Not too great for the battery, but we do see that when we're camping, right? So that is easier to detect with something very simple like a few LEDs that's going to tell you in the range where you're at. Lithium is not the same. Lithium voltage curves are very flat until they get down to about 15% and they drop off hard down to nothing. They cut themselves off and turn off completely. So what we need to know about monitoring lithium batteries is there's two ways to do that. On the market now, there's a lot of batteries that are Bluetooth capable. They have an app that goes with them. They emit a Bluetooth signal and they have all of that stuff in the app. It tells you how much current you're using, what percentage they're at, and how long you might have left in the battery at your current usage rate. Some of them have that, some of them do not. So a lot of times you'll need to look. If it's Bluetooth, great. You don't need to buy this next component that we're talking about. However, if you have a standard lithium battery that is not Bluetooth capable, you are going to need what's called a shunt. A shunt battery monitor is a very simple device that takes the negative from your battery post to one side. That goes to battery minus here. And then everything else for your negative side of your loads is going to go to system minus. That's very important. But the whole concept of a shunt is that it monitors all of the power from the battery post to the loads. So anything going in or out of the battery is measured across these fins, and it measures it in a millivolt measurement to know exactly how much power is either being pulled into the battery from a charging source or discharged out of the battery to a load like your water pump, your inverter, or anything else that you're using. That is the only way to accurately measure the state of charge for a lithium battery because of that voltage curve is so flat. You will never know. If you throw a lithium battery that's rated as a drop-in replacement, right? All of them have that. All of them say it. It's incorrect. They're not drop-in replacements. They will power your stuff correctly, but you will not have the same functionality or the same monitoring that you had with the lead acid unless you have something that's going to tell you where that battery is at. So that's the monitoring portion. Let's talk about charging. Charging sources in an RV application. You have your battery charger when you're running your generator or on shore power. That is also referred to as a converter. We have two different types of converters here to look at. One of them is for a 50 amp RV. So if your main breaker on your RV panel is a 50 amp double breaker, you will have this guy here, a larger one with a standard outlet plug. Sometimes they're a 20 amp plug with the sideways prong. Be cognizant of that when you order. The converter takes 120 volt power in and it puts out DC power on here to charge your battery system. When you have a 30 amp panel, when your breaker in your breaker panel, the biggest one is a 30 from shore power or generator, you're going to have something similar to this. You'll have it wired into your breaker panel through these small wires, and then you have battery output from here for your positive negative to charge your battery system. Same idea. Nothing has changed, just a little different style of how they're made. So it takes 120 volt power in, puts out 12 volt power. The issue we run into when people swap out converters or don't swap out converters when we swap in lithium batteries for lead acid is that lithium batteries run about a volt higher than traditional lead acid batteries. Converters are designed so that when you start charging the battery through that method, so you're running your generator, it's charging up your battery that way, all of that power is going into the battery until the battery gets full. Once the battery starts getting full, the circuitry in a converter is designed to start tapering down that amperage so that it doesn't overcharge the battery. It turns into a float charger. So if it's a 70 amp converter, it's going to try to put out 70 amps until that voltage comes up high enough where it senses that the battery is nearly full, and then it's going to taper that amperage back off. Well, if you have a traditional lead acid converter, that voltage is going to be around 12.8 to 13 volts. Once it starts sensing 13 volts, it's going to start tapering that down because we don't want to overcharge a lead acid battery. And that's what that converter is designed to do, a lead acid charge. If you put a lithium battery in, now your converter is going to see that higher voltage of a lithium battery, and it's going to assume your battery's full, and it's going to taper that amperage way down. This becomes a problem because when you're camping and you are down to 10% on your lithium battery, oh, I'm going to fire up the generator, give it a couple hours, and I'll have this thing back full. That's not going to happen. You're going to fire up your generator. It's going to start charging initially. And then as soon as it senses the higher voltage of a lithium battery, it's going to massively taper down the output of your converter until you're doing almost nothing. So you'll be down to a 70 amp converter might put out 2 to 5 amps. Once it senses that in its normal form, charging a lead acid, okay, we're nearly charged, we need to taper that down. You're going to be putting out very, very minimal amperage. So what does that mean? The less amperage going in, the less charge you're receiving, and you are going to run that generator for about 15 hours to try to get half of your battery charged. Not efficient. The only way to remedy this situation is to swap out your lead acid converter for a lithium style converter, a lithium compatible converter. Any more questions on that kind of stuff? We have a video specifically on that. You guys can check it out. We'll leave it a link in the description. And it goes through all of those things, how to do it, where you'll find them, and the different styles of converters. And it goes a little bit more into that. So charging, that's one portion. You have your converter. A lot of people today are solar charging or have other passive means of charging. Those are usually just an update either to the software or changing settings. So let's talk about that a little bit. When we're talking about solar charging, we are talking about changing the settings on our solar charge controllers. I have two examples here. One of them is from Victron. One of them is from Renogy. Those are the two brands we see most coming across. We pretty much exclusively use Victron now. So these two components, they are only going to charge to the parameters you tell them to charge. They take the same power in from the solar panels and it runs through the charge controller algorithm and it spits out a voltage that's good for your battery. There's no way for it to know that you changed your battery other than by telling it what to do. So we got to go into our settings here and we tell it what voltages we want the battery to charge to, or we're going to run into the same problems of not fully charging our battery or getting extremely slow charging through the other means, just like we did with your converter. Change the settings, everything ramps back up, it knows what it's doing, and we're off to the races. So, two main things, don't make it overly complicated. You got charging and making sure that all of your charging sources are correct for a lithium battery, whether it be settings changes or swapping out the physical hardware for a lithium compatible converter. And you have monitoring. If you change the battery from lead acid to lithium, you need to install a shunt or make sure you get a Bluetooth capable battery that is going to display that information for you so you always know where you're at in your state of charge. Like we talked about, the dummy lights where you push the button with the lead acid battery, you'll show 100% full on a lithium battery in that same situation where you push the button. You'll show 100% full almost until it turns off. It will not register a lower voltage until lithium is almost dead. So super simple, don't overcomplicate it. If anybody's trying to make it more complicated than that, they're wrong. There's only two things you need to worry about: charging and monitoring. Good luck, guys.